that, our knowledge of filters was relatively limited. So this is the filter that we built for Field Day last year. It's a Butterworth filter. It's a very, very simple design. Turns out they're a pain in the butt to tune. But they give you a nice flat pass band, and they're not so great on the rejection ratio, but it got us through winter field day. Now, we're not up to snuff with some of the contest groups in West Central Florida, but we were #1 in the nation in 4F. And we were #2 in the nation in all F. There was a group in Rhode Island that beat us out in EOC associated stations. So we were pretty happy. This was about our 4th field day, and to hit #1 in the nation in our class category, #2 in our category, we were pretty happy with that. Our bandpass filters that we built in paint cans had an insertion loss of about 0.5 to 1 dB. The next band separation, it's a Butterworth filter, so the skirts are not real sharp. So our separation was only about 20 dB. Between 20 meters and 15 meters, which is not even a factor of 2 frequency, it wasn't even that good. Nevertheless, it got us through field day. So now we come to our EOC. We did our field day at this alternate site location, but we wanted to see if we could operate at our EOC for winter field day. And the problem with our EOC is it was designed a long time ago, and it had only one coax cable. So we've got one HF cable. We have several VHF, UHF cables. They're all 300 and 400 feet long, but for HF we only have one. At summer field day, we had set up 7 different antennas, and we had them as far apart as we could possibly get them, and we still had some issues, and now we have one cable. So how are we going to do this? Like I said, we don't really know much about contesting, so we learned from the legacy group in our town, the Gainesville Amateur Radio Society, that they have these things called triplexers, and they're designed to allow you to put 3 transmitters on a single beam. And like that sounds like what we're looking at. We need to have multiple transmitters on the same coax, and it's the same problem. So it turned out this was all started by a hand named Gary Gordon. Looks like I have 2 R's and started. In 2010, he came up with a proposal to do exactly that for field day. And here's the trick that you need to know. Series tuned circuit right there. And Gary built series tuned circuits so that the radio, each radio went through a series tuned circuit. Do I need to switch to this one? Sorry, I'm making y'all go back and forth. The antenna connected to this end, and then a series tuned circuit went to each radio. So the advantage of a series tuned circuit is the impedance is high everywhere except the resonant frequency, where all of a sudden it begins to connect you good and solid. Series tuned circuits with one section don't have the sharpest filtering, but it beats none. So the original design that Gary did has been modeled like this. You have several different radios. Each one has a series tuned circuit, and then that goes to the antenna, and the power gets split between the 3 circuits. So although there's 3 different signals and potentially 3 different transmitters or receivers, they're separated by frequency from each other. The separation is not that hot. So Gary was pretty straightforward. In addition to his triplexer, which was a simple set of series tuned filters, you also needed a bandpass filter for each radio on its band to get more isolation, because you simply just don't get enough from this triplexer job. Here's the curves for his triplexers. And I don't think I can read that from here, but that's 20, it's supposed to be 20 on his spectrum analyzer. and that's supposed to be 80, but his attenuation just wasn't that hot from just the series tune circuits alone. If you added the bandpass filters, it became tolerable. Now, what you basically need not to destroy radios is very important, because you've got 100 watts coming out of transmitter, 50 dBm, and if enough voltage gets to the next guy's receiver to forward bias his diodes, you could start blowing out his expensive transceiver. So 0.6 volts peak will forward bias diode. So I adopted that as the possible chance of damage. Doing a little math, that's 5.5 dBm. So the damage threshold is around 45 dB of separation. But that doesn't mean you can operate, that just means you go home with a still working radio. So if you look at S9 plus 20 dB, which would be an extremely strong signal in the band, that's negative 73 dBm. It's very unlikely that we can take a 50 dBm signal and get it all the way down to negative 73 dBm on a nearby band. That would be 120 dB of separation. Most repeaters have around 70 dB of isolation at 2 meters, and they have to use mechanical duplex filters, cavity filters to get that. So what we were shooting for, if we could get 60 dB of separation, we would have 10 dBm going to the receiver from a 100-watt signal, and that would be 70 millivolts. You probably will be able to still operate if it's on a different band. So you're on 40, and there's a 20-meter signal coming into your receiver from the transmitter of the guy beside you at 70 millivolts, and you might be able to survive that and keep operating without desensing your receiver. Okay, well, the contest guys had gotten this to work, so we followed their lead, and this is Pavel, I forget his last name, a Canadian ham with an Eastern European name, built this kind of a triplexer, and he sells it as a kit. Now, he also sells it as a fully built item for like $500. But the kit was more like $200, and we bought it. We learned a lot from his kit. This is us working on his kit. He used much bigger toroids than what we knew to use, because the ARRL article suggested T80 size toroids, and he used 130s. The ARRL suggested relatively small wire. He used number 16 wire. The ARRL article suggested a minimum of 500 volt capacitors. He used 3 to 6 kilovolt ceramic capacitors. So his was much beefier. We'd never even thought of this. One of our guys, that is Eric right there, and he had a nano VNA. Well, it's a whole lot easier to use than my Signet spectrum analyzer, which is right there, because it can measure not only the filter performance, it can measure the SWR at the same time. You can do S11 plus S12 at the same time. And the way you tune these things, you solder in the capacitors, and then you just start shoving the turns of the toroid closer together or farther apart. And we were amazed. It makes a big difference. And you can actually tune these things by just shoving the turns of wire around. So we got introduced to how you do this thanks to VA6AM. Now this is his schematic. He's not the greatest at writing instructions. He's pretty good at designing stuff, but his instructions leave something to be desired. So we had to go through and add how much capacitance and how much inductance every one of these was, because you couldn't figure it out from his schematic. So this document, once it was built, was worth its weight in gold to us, because it told, here's what you actually need to find in this kit to put this together. So here is the original build. The way we took it, we took his design and we simply tuned it the best we could. Right out of the box, The numbers that are in parentheses are what we got right out of the box. And then the numbers below them are what we got after we tuned it. So for instance, the passband loss on 20 meters was half a dB. We got it down to 0.2. The passband loss here was 0.28. We got it down to 0.18. Here it was half a dB. We got it down to 0.29. Now, he gets his much better, according to his data. We don't know how he does his measurements. His measurements are like 0.06 dB. I don't know how he does it. He may be making handicap adjustments for the connectors. I really don't know how he does it, but we could not get his numbers. But these numbers here are really good numbers. These are very low insertion loss. When you're working at an EOC that has 300 feet of coax, 0.2 dB in a triplexer is nothing. Now these are the isolation from the lower band below it. And here we had 38 dB isolation, 31 dB isolation, 42 dB isolation. We actually made this a little worse when we tuned for best insertion loss. But those are very respectable numbers from the triplexer alone. Not any added bandpass filter, just the triplexer. His design is far superior to what Gary Gordon started with just a simple tuned circuit. So we were pretty happy. You still need external bandpass filtering, but you only need about 20 dB of it. And that's not hard to get. 20 dB of bandpass filtering is a cinch, unless you're using Butterworths. But at any rate, this was not good enough for us because running 20 and 15, 10 is not going to get us through winter field day because there's night. And we need 40 and 80 to work. And in the glimmer, we were thinking, what about 160? So we need to add another band. And it took us a long time to understand what Pavel does. And he does a very cool trick. When he puts a tuned circuit together, he has a series tune thing that everybody uses. And then he'll have a trap for the lower band, 20 meters, which shorts out 20 meter energy. And then he'll have a trap for the 10 meter band, which shorts out 10 meter energy. But the 10 meter trap looks capacitive at 20 meters. The 20 meter trap looks inductive at 15 meters. And the two together make a parallel tuned circuit at 15 meters for his 15 meter system. So he's not only got a 20 meter trap, a 10 meter trap, he's got the two together make a 15 meter parallel tuned circuit. And that's his brilliance. That's how he gets his excellent outcomes. So once we learned that was his trick, that he uses two traps to make a parallel tuned circuit, we started being able to do things. So here's my attempt at turning his 20 meter low pass filter into a 20 meter band pass filter, because we have to do that or we can't add a 40. And in order to do it, I added a 40 meter trap here, and I had to add a compensatory inductor because I didn't make the math work out so the two traps worked right. I wasn't quite smart enough. But it did work. So here's my 20 meter response, and I've got good pass of 20 meters. I'm sorry, this should be 40. Yeah, this is our reworked 20. So our reworked 20 has become a bandpass filter, and it now has a notch at 40, and it has a notch at 15. So it's starting to work. This was so interesting that we're adding and subtracting complex numbers by adding that parallel inductor to tune out and resonate at 20 meters, that I took this to my pre-calculus students who were at that moment doing complex numbers in vector format or in rectangular format. And we stood there with the spectrum analyzer. I put it in linear mode because at that point they didn't understand too much about dBs. And you could add and subtract this inductor, and you could see the bandpass work or fail. So they got to see how this works. Math in real life. 3 very brilliant young ladies, not terribly interested in radio, but they need to pass AP pre-calculus, and so understanding that this math is actually used in real life was probably helpful. Now, Pavel does a very complicated way of adding extra bands. He builds a diplexer at first and splits off a triplexer for 2015-10, and he does a diplexer to get to another band. And that's another $500. So you're looking at $500 here, $500 here, $500 here. It adds up. So we weren't willing to do that. So we said, we got this very fine triplexer, which we've now made the 20-meter section be a band pass instead of a low pass, so it does not pass 40. Can we add a 40-meter band pass to his triplexer and make a quadplexer? So we simply took his numbers and rejiggered them for a lower frequency and came up with this. And our 40-meter needed to have a 20-meter trap, and it needed to have an 80-meter trap, and the two together needed to make a 40-meter parallel tune circuit. And we were able to do it. So we were predicted to have such and such number of turns, but we actually ended up with 17 here. The 20-meter trap, 17, the 80-meter trap, 15 turns. And we did it in Pavel speak with big inductors. And these were the capacitors that we used. And we learned from Pavel what good capacitors look like, and we discovered that they're available on Amazon for dirt cheap. So we started actually making real good progress. And here is our 40-meter band pass, designed the way Pavel does things, but in a separate box because we've run out of space. So we've now got our 40-meter added filter. And there's our 40-meter response. So I showed you before the 20-meter response, but we have now built a 40-meter filter which passes 40, kills 80, kills 20. And that's what you need. You got to help out the nearby bands. Those are the ones that are, the bandpass filters are not going to do so good for the nearby bands. The bandpass filter is going to be fine for the far bands, but not for the nearby. So we've got a pass band of 0.21 dB. We've got, looks like the 80-meter response is negative 27 dB at 3.5. Negative 28 at 4 megahertz, and the 20-meter is negative 48 dB, so it's excellent for 20 and tolerable for the other bands. So at this point we had a quadplexer. We've now taken his triplexer and we can run 4 transmitters simultaneously. Our 40-meter passband loss is 0.36, 20-meter passband loss is 0.23, 15-meter is 0.49, 10-meter is 0.3, 0.43. As you add extra sections, you unavoidably begin to lose more energy because there's another parallel part to your system that can absorb unwanted energy. So we kind of had a quadplexer. So then the idea is, well, could we make a quintplexer? Could we add 80? We were getting kind of tired at that point. So we stole another idea from Pavel. He tends to use a low-pass filter on the bottom band and a high-pass filter on the top band. So we stole his low-pass filter and we built a low-pass filter for 80-160. We didn't do a very good job, but it was tolerable. It looks like it's around 20 to 40 dB on various bands. And it allows us to operate either 80 or 160, but you can't do them simultaneously, but it means we can now operate 5 transmitters simultaneously on one piece of coax. Well, the way we did this is kind of a crappy picture because I blew it up. We had one box from think that's Pavel's box, I think. And then this is our added box, and we simply connect them with a really short piece of coax, and it worked. So we can separate them, and we can use one as a 4080, or we can put them together and use all five. So we have lots of ways to do it. So here's our Quintplexer response. On 8160, it's 0.35 dB, 40, it's 0.35, 20, it's 0.23, 15 is 0.49, 10 meters is 0.43. These are not great. They're nowhere close to what Pavel would get, but when you're faced with 300 feet of coax, these are tiny. And our isolations are decent from other bands. Pavel has better bandpass filters than what we had, so we are slowly replacing our bandpass filters with Pavel's bandpass filters, which gives us even better separation, but we buy his kits to save money. This is where you get the parts. 100 picofarad and higher values, there's an assortment you can buy from Amazon for 20 bucks, and it gives you like 100 capacitors. It's fantastic. You can get some silver micas at 500 if you really want. You can get a bunch of supposedly 500 volts, but when I looked through those, they're not all 500. DigiKey has the TDK 47 picofarad, 22 picofarad, 10 picofarad, and a few others rated at 6 kilovolts. They look identical to the Amazon assortment that's right here for 20 bucks. So if you put a few orders from DigiKey together with 1 or 2 orders from Amazon, you can get an astonishing assortment of very high voltage capacitors, and they actually work. So did this work? So this is our radio room table at the EOC, and here are our filter boards. There's our triplexers, 2 of them, so we now got the Quintplexer. And then here's some of our paint can filters, and then here's some of Pavel's filters that we bought, and one of our guys cut holes in aluminum boxes, and we mount them with brass standoffs that you can get cheaply from Amazon. And we had coax going everywhere. We have 1 power meter, and it goes to the 1 piece of coax that goes to our antenna. Now we had to change our antenna also, because to get this to work, the antenna needs to be close to 50 ohms on every band. So we had an off-center fed that was really good for handling all federal frequencies plus ham frequencies, but it was not really great on all the ham bands. So we switched and put up, we improved our in-fed half-wave. We went to the My Antennas 2K Plus. It's got a better ferrite than the 43 type ferrite that we can get. We can't get whatever their ferrite is. They've got much better performance on 10 meters than what we were able to get. So with that better antenna, we put all this together, and it was really amazing. We had never done this. We are connecting transmitters to the same coax, and we're going to find out if their receivers go when we hit the key, right? So we did a little ginger at first, but it was amazing. We could bring 3 transmitters online, and that meter would show 300 watts running down the line to the antenna. As you added transmitters, you could watch the needle go higher, 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 and it's all working. And everybody's receivers are doing fine, and we're all hitting the key, and it's like, oh my, this is what the repeater guys did, you know? We're doing it at HF. We had it in one of our training sessions. One of our people got a little confused, and he was on a 40 meter something or other, or I think he was on a 20 meter tap, and he turned his radio to 40 meters. Hey, my radio's busted, I can't hear anything. Because the isolation was like 50 dB, so all of a sudden he wasn't connected to anything because he was on the wrong band. And of course, if you hit the key then, you can do some damage. So we had to teach our people, you absolutely must stay on the band that we tell you you're on. And we built little pine wood derby placards. You're authorized this band. And we would hand those out to stations to put on top of their transceiver. This is you. And if we needed to change it, only 2 guys were allowed to go muck with all the coax and put them on a different band, because we only had 2 long pieces of coax to go into the other room. So we had to be very careful how we did that. But it worked. So for the very first time, we are pounding away. We have 3 stations in 2 different rooms running. All these stations are running simultaneously in one room. And then the main station is in our main radio room, pounding away 3 100-watt systems, and we did it for 24 hours. And nothing got blown up except one thing. These are happy campers trying to work voice. The CW op, oh, that was me, blew them away. But we learned a lot from that. We learned what works in Winterfield A and what does not work in Winterfield A. It's another one of our courageous voice operators at the main EOC station in front of the filter table. And that's how we kept track of how we were doing. Some of our people did not understand how Winterfield A scores. We had to teach them. There's these things called multipliers, and you want them. And you get them by going to other bands. And you get them by going to CW or PSK or whatever we don't have. And I need a number in every one of those boxes. And all of a sudden, people begin to understand how Winterfield A is scored. It's designed to force you to try things that you might not ordinarily know how to do. So we thought that was good, because we want our people to be extremely flexible. So this is one of our elderly members who has had a few small strokes and has a few different little mental issues. And she made her first Morse code contact. But she can't copy a lick of Morse code. Doesn't know squat. Probably couldn't even figure out SOS. So she was using a CW decoder during a contest to read Morse code in pileups and respond. And she did make a contact, for real. So we were very proud of her. And the guy beside her actually knows a little bit of Morse code, but not enough to compete in a contest. And he's helping her out. And the next thing she did was she went to PSK on FLDGI, and she said, "Oh my gosh, this works." The CW thing is crappy, but this copies. Well, of course it does, because it's made to, right? But she learned something from that. And then at 10 o'clock on Sunday morning, we have about 4 hours to go, and our operator in the main room, he's a gerontologist from India, works at the VA, said, "I smell smoke." And this guy comes running out to me. I'm on 50 meters. "Gordon, stop!" So they opened up the paint can and smoke poured out of it. These are supposed to be 3 capacitors in series to make 33 picofarads out of 3 100 picofarads. And that's not black because it's in a shadow, it's black because it's charcoal. So it got toasted. And you can see our handmade inductors there. These are pretty crappy inductors. They're built on dowel rod and they're secured with hot glue once we got them to work. It's not one of our better filters. Believe it or not, I had brought spare capacitors with me and soldering iron, and we rebuilt it and had it back on the air. And I actually finished the contact because all of a sudden I saw my signal levels drop by 20 dB, and I knew something bad has happened, but I need to get that contact. And somehow or another I managed about probably milliwatts of power to finish that contact. So our group managed to do 111 CW contacts, 129 phone contacts, 64 digital contacts. We hit a score of 10,000, which we hope we'll get to keep after they check the logs. We had 13 on-site operators. We had one particular guy that helped us with off-site contacts. We think we'll be in the upper 4% of submitted Winterfield A logs. It's our very first Winterfield A. We've never done this before. But we studied the rules and we thought we knew how this would work. This is a graph of contacts per hour by different modes. In blue is Morse code. And that is 30 minutes out of an hour on 20-meter Morse code. And we learned a lot from that. We thought that people were going to use JS8. Nah, they didn't touch it. We thought folks were going to do RTTY. Nah, there wasn't any RTTY. It was all PSK31. everything. We were, never expected that one. So our training was all fouled up, and we learned that if you do Morse code, you can just whoop the voice guys up one side and down the other. There's no comparison when you're going through 300 feet of coax. Morse code versus single sideband wins every time. So our conclusions, we've got to replace the 15-meter filter that bought the Ghost with a Pavel kit. We're always going to use T130 size toroids instead of T80. We're always going to use the biggest wire we can get our hands on. We're always going to use 3 or 6 kilo ceramic caps, which work much better and are far cheaper than mica 500 volts. You really want 60 dB of separation. One time, the 40-meter station and the 20-meter station had it tuned to the second harmonic, and they could hear them. There's no question. This separation is not perfect, and you will hear harmonics if you tune to the harmonic frequency, but it doesn't damage anything, and you get away with it. We have a Yagi that we're going to try to assemble, and we ran into trouble at 160 because we couldn't do 80 and 160 at the same time, and in the middle of the night, 20 was dead, so we were stuck with 80 and 40, and we really wanted a third band, so we're going to try to change our 80 meter to have a 160 tap and really have a tri-bander at the bottom band.
But you say you want to get a Yankee. What kind of a Yankee you going to be using?
It turns out that the EC in the county had a TA-33 Junior, Mosley, zip-tied to his fence posts in his backyard, disassembled. And he wasn't sure what it was. But when he laid it out, it was pretty clear what it was. And so our spring goal is to assemble that Yagi. We've never done that before. I don't know squat about them. Built a quad when I was a kid, but this is our first chance to build a Yagi. We already have a tower because a guy who's welded together some stuff for us. We have a tilt-up tower, telescoping tilt-up. So we're going to try to put a Yagi on for summer field day.
That's in 220, right?
Yeah. That'll give us some gain. We've never had gain before. But we're pretty good at end feds and off-center feds, and we handle 80 and 40 without any problem. And we're good at putting the antennas at every end of the 1,000-foot circle, and we have trailers and RVs, and we managed to get, we were working 2 stations, one on 20-meter Morse code and one on 20-meter digital at the same time during summer field day last time. It was a little hairy, but we managed to do it because it was hot and we were getting lots of contacts.
You mentioned the 2K Plus that you use. What type of thing is that?
The 2K Plus is it's a My Antennas product. Let's see if I can get it for you.
They're a Florida company, I believe.
I don't know where they are, but yeah, they could be. It's a Ballon, and it's not cheap. It's 270. It's about $200 just to buy the Ballon. Where's the Ballon in this picture? There, that's the Ballon right there. So if you look at type 43 ferrite, which is what we use for almost all of our Ballons, at 10 megahertz, it begins to have a resistive loss component that begins to exceed the inductive desired component. So our Ballons were tolerable at 20, not so good at 15, and sort of sucked at 10. But that was all we had, was type 43. We couldn't get anything better. There are better ferrites, we just can't find them. I think it's, I've forgotten how, it may be type 52 or something. There's a better ferrite for 10 meters, and apparently they have it. Because they cite the fact that they used a different kind of toroid, they cite the fact that it has lower loss, higher Curie temperature, and type 43 has a Curie of, I think, 125 or 150 Celsius. And this other type, whose number I've forgotten, is more like 175. So they have the better ferrite, and I can't find it. So my team was stunned. You're actually recommending we buy something ready built? Yeah, we're gonna have to this time. So we have one of these, and one of our team members has one, and I'm gonna try to buy another. but it's a better balun than what I can make.
But that goes on to the end fed.
Now, the reason is it gives you a good SWR on every beam. And you need that. It's an advantage to you to have that if you're using an antenna multiplexer that's filter based. Because they need to see 50 ohms. They're designed for 50 ohms. So we did all this and it worked. One piece of coax and we think the top 4% of the logs with one piece of coax. We were very excited. And our team members are not contesters. We're run-of-the-mill hams, and we're slowly learning how to do this. It was about halfway through when they finally figured out, oh, you mean we take the number of points we get and multiply by the number of multipliers? Yeah, I've been trying to say that for 3 months. Oh, you never explained that.
I don't know, I can't remember at Winfield, Summerfield, if you have go-to stations.
You can get extra points, but our group is terrible at the go-to station. We're just terrible. We're much better at FT8.
I have worked in the past with the top 3A station in the country up in Indianapolis.
Oh my.
And then 2 years ago, they made the top score overall in 3A, and then they moved to 4A this last year.
Oh, they're gonna kill us, because we think we're gonna be 3 or 4A this year. They're gonna kill us.
Yeah, they're hard to go against.
We're just run-of-the-mill. I mean, a lot of the guys in the group, we taught them all the way through the extra. That they're our babies, and they only know what we taught, and that's limited.
But we have a whole big grounds, which used to be an RCA clubhouse and grounds, and now it's Victor Conservation Club. And we go there and get in.
Cool.
It's all over the place.
Yeah.
We got a clubhouse, and we operate out of that. We
Oh,
bring
cool.
campers in and run
Yeah.
CW out of campers.
Oh yeah, that's the way to do it.
It's
Get separation.
totally
Get separation.
Totally different operation.
We were thinking about doing remote control through Arden Networks or something.
Yeah.
And remote control stations in RVs or trucks at the edges of the 1,000-foot circle. We didn't pull it off, but it's in our thought process.
We just run a lot of coax.
We all bought coax last year. We had to get around 400 feet of new coax. And the guys ragged on us until we bought good coax. So we now own better coax. We now have a tower. We're about to have a beam. We've got this Quintplexer. So our Aries group is just adding assets right and left. And it's all driven by competition. You gotta learn how to do this digital. You gotta learn how to do this voice somewhere. You gotta say, mic fright. Gotta get them over it. Gotta do this. So, you know.
What town is that? Gainesville?
We're actually in Gainesville, Florida. There's a Gainesville Amateur Radio Society, but they're kind of the legacy club. We kind of split off, and we've been trouncing them ever since. Every year we trounce them.
That's what happened to this group in Indianapolis. They were the RCA radio club, and they split off. They got the best operators in the whole 5 or 6 county area.
Well, we could not get some of the older folks to listen to our new ideas, and so we just, all right, we're going to do it our way, and we just trounce them. They're very good at sociable stuff. They're very friendly, very good group for that, and they're just not very good for competition. Everybody's different. Advantages to everybody. All right, any other questions? All right, I'm going to consider that done. And then I think I'm back here for about half the afternoon.
Yeah, you're jumping back and forth all day.
Yeah, and they don't have a HDMI in the other room, so it's kind of making it harder to demo. Because I have a live output from the SBitX, but I can't show it. And I put cables in just to
stay in this room.
Hmm? Sorry?
It seemed like they should have just left you in this room.
I don't know, whatever. Maybe they thought people might like to see the SBitX. It's a really cool radio, much better than it was last year.
Is that akin to the Ubitix?
Yes, it's the big brother.
Big brother.
Way better.